Broadcast is now starting. All attendees are in listen-only mode.
Hello, good morning, good afternoon, everyone. Before we begin, I would like to make sure that you can see my slides, that you can hear me. If you can use the attendees pane, just click on that hand icon. Kind of give me a high five if you can hear me. Okay, thank you, Richard. Thank you, Valerie. Okay, we are good to go. On behalf of Web-based Solutions, I would like to welcome you to our today's webinar, Getting Started with NiFi. My name is Mikhail Vladimirov. I'm with Web-based Solutions. We provide a broad spectrum of a variety of regular and customized training in a variety of topics. So our recent focus is on providing kind of enlightenment. We're trying to measure the interest of people who would like to use something that resembles an enterprise service bus, which is distributed, scalable. So NiFi falls squarely into this category. This is a quick overview of its technical overview. There will be no kind of a business kind of a lingua or something. It's more about showing the capabilities of NiFi, what it can give you right away. I will also share my experience working with enterprise service buses and just maybe draw some parallels so that you will see some analogy. Probably it will catch your eye right away. So let's get started. So NiFi, that's how it gets pronounced. It's a distributed data flow automation platform. In essence, as I said, it's an enterprise service bus, and I will give you some examples, and you'll probably, as I said, would recognize that that's how things are. Interestingly, it was software developed by National Security Agency. It's a federal spy agency in the States. Just don't confuse it with NASA, because some people believe that NASA was the company. NASA was in partnership with Rackspace to donate Swift large object. It's for the cloud. And it has been open sourced. So it's a very nice move on the part of NSA, and currently all the development, I guess, the disclosed part of it has been further developed by open source development community, and currently Hortonworks, the vendor of Hadoop platform, offers NiFi as one of the products in the product ecosystem around the Hadoop core. So written in Java, not everything, but I guess the majority, and that's where you will be, I guess, extending NiFi, because it's NiFi. It's an extendable system. You can create your own processors. If you haven't satisfied your kind of needs using like 200 plus processors, you can do that. It's an open system. And for that, you will need Java. Currently, it's being positioned by Hortonworks and other vendors as a platform for efficient handling of the Internet of Things. So when our world is becoming increasingly integrated, where you have lots of sources of data, it can be sensors, it can be social media feeds, and all those things, they need to be processed in a secure and scalable fashion. So NiFi seems to be fitting that bill quite nicely. Of course, there are more use cases, and you will see in a moment where it actually shines. Those people who have been in enterprise and processing large data sets, you know of all the possible problems, challenges, gotchas that you would be facing when you process really kind of mission critical or large data sets. You can have network problems. We're talking about distributed data flow. So if everything is done on a single machine, that's probably not an issue. But if you have a distributed network where you move things around, probably from production into your data centers, or maybe you have a partnership link with your counterpart agents where you need to share information in a secure fashion, large data. One thing is just to FTP, have an FTP job, or maybe get some data using RESTful service, or any just probably sending a file as an attachment to email, doing it the right way. Then it's probably not a big issue, but there is more to it. And you know that there are tasks related to augmenting data, maybe purging data, priming data, removing outliers. Lots of things are happening during that value chain where you would like to prime your data, cleanse it, make it suitable for further processing. And lots of things just kind of lurking in the dark alleys. You might have problems with unpredicted spike in data digestion, or there might be problems related to formats. All of a sudden, that particular XML document is not properly formatted, and you'll choke. So what would be your strategy? So NiFi seems to be kind of aware of those pain points, and it tries to come up with just one-size-fits-all kind of a solution, right? You can have resource under provisioning. So how you would handle this? You need to probably to create 2 or 3 nodes handling the same task. So kind of a small farm of nodes that would be working together towards processing any possible spikes. Compliance, security. So compliance would be something that you need to provide you need to provide tracing. You need to trace data to the source, what happened to the data, kind of an audit trail, if you will, so that if the controlling agency comes in and they would ask you to produce actually hard facts, you would need to produce those things, so that the data hasn't been somehow that kind of a proverbial needle kind of disappeared in the haystack. It shouldn't be the case. Right, security, data needs to be securely delivered. So probably it would be point-to-point security using SSL, TLS, but also content encryption, right? So it's possible that when data traverses between the endpoints, it's secure if they're kind of SSL endpoints, but further down the road, until your data reaches the destinations at white zone, quote unquote, the content might be tampered with. Because when it would be unencrypted, going along the line in plain text, lots of things might happen. So for that, security around that workflow should be in place. Also, multi-tenant authorization. So who has access to which part of the system when? There should be that authorization policy management in place. So lots of those things, and those are becoming really unmanageable tasks if you increase your wide area network. It might cross continents, it might cross boundaries of states. So it's kind of a tall order. So NiFi is positioned to address most of those, if not all of them. And NiFi gives you capabilities for data routing. That's what their strong points. Data transformation, system mediation, so that your message can be looked up and depending on the contact and can be routed. So all those things just fall squarely on that use cases of distributed ESB, whether it's IBM's MSMQ or similar products, or maybe kind of a more accessible system, Mule. If you have worked with that, it has that very nice kind of a Swiss Army knife type of capabilities with RESTful endpoints, HTTPS, SSL, messaging, all kind of those interconnected things are possible. And Mule also comes with, as well as other kind of higher-end products from TIBCO, from IBM. They have some sort of integrated development environment where you would have a studio allowing you to drag and drop those processors, connecting them, setting up properties of configuring those links so that essentially you have a visual representation of your workflow. And then you persist it and you would create some sort of archive file, kind of a jar file, which you can deploy on the system, which would work according to the spec. So that's very kind of a close approximation. Essentially, it's a distributed NiFi. NiFi is distributed ESB. Messages or those events that flow through the system are called flow files. So whenever you see that term, just think messages. So it has the nice admin console, which is also serving as your development console, allowing you to quickly put together a flow, a simple one, a complex one. You can also use that UI for kind of managing, controlling, getting some metrics, statistics on the flow. Data flow tracking, wall to wall, since the ingestion point all the way down to the point where your data gets processed. Yes, by the way, I didn't mention this. If there is a question, just don't hesitate to put the question in the questions pane. By the way, the link should have been provided to you. It's a PDF file, not PPT, not PowerPoint. Navim, so I can, I guess, get back to my people, but it will take some time. There should be a link, so since you have been able to connect to this session, alongside with that link was a link to the document to download. If you haven't found it, closer towards the end, I will check with my people. Okay, so yes, the slides are available. That slide deck is definitely a useful thing. So data flow tracking, it's for audit purposes, for compliance, for lots of reasons. So essentially, you need to know what's happening in your world. Particularly if you are an admin and someone is just asking you a question, so what happened to the particular flow? We've lost a very important flow file. You just need to have a way to track it down. This term, tracking or auditing, is quite fancily named data provenance. So data provenance, essentially, it's a way to trace kind of that flow file through the system. It's like the tracking number if you have UPS or FedEx. So that's how things are. From one kind of data processing center to another, and you know the time when it entered the system, when it left, the stay time. Back pressure is a way to deal with the spike of requests. Essentially, it's a way to cause that client which just floods you with messages to slow down. Essentially, they just don't respond to that socket kind of a handshake. It's essentially, you treat it as a denial of service attack, and you just kind of a handle, you, in order to remain sane on your end, you essentially shut down your client. It's not very nice, but at least you safeguard your system, and then you'll probably figure out. At least you can say, we haven't accepted that particular important message, and therefore, through our provenance process, through our audit trail, we say that at this point in time, we didn't process. And by the way, the client would also see there would be an exception on the client side saying that not able to connect to the system. Probably it would be kind of a 500 type of error in HTTP response codes. Guaranteed delivery is interestingly that system is quite configurable. So it can be exactly once, and all our other messaging kind of patterns can be enforced. The system is secure, so TLS, SSL, encryption of the content are supported. You can also sort of balance various aspects of your quality of service. So quality of service is something that you need to establish and back it up with an SLA agreement, service level agreement. And in that SLA, you will specify that non-functional requirement that there should be kind of a higher throughput over latency. So we can kind of tolerate kind of having higher throughput kind of because we really want to achieve that latency. It's okay to lose some of the messages. It's not a big problem because we can reconstruct, or in other extreme cases, we can support duplication of messages. It's okay because our system has some sort of a correlation ID, which would essentially discard any repeated broadcasts. Right. So it's very important. So essentially, the system has all that capability built in, which you can just use some configuration kind of knobs to set up the proper level of your expectations. And artifacts for developing custom data processors. Artifacts means there are classes, there is a toolkit for that, there is abstract classes that you just need to extend. You would need to use Java for that. I'm not sure about Scala, probably they do Scala as well because it's a JVM based system. So the question is, how is this compared to Spring Integration Framework? Essentially, yeah, it's very close. It's very close, but you need to compare, I guess, bullet by bullet, just to go feature by feature. And what's interesting, what used to be true maybe 6 months before, in the next release would be fixed. And a new feature would be introduced. Kind of essentially, the major rule is use whatever system you are familiar with, because if you're familiar, you can get you can squeeze more out of it. Right? Some people might be very well suited by using the existing infrastructure systems. Right? It might be Mule, it can be MQ messaging, it can be TIBCO, you name it. Single node, if you have just one JVM deployed on a machine, sure, it should be a host featuring multi-core, lots of RAM, 64-bit JVM, which has embedded web servers through which you would have access to the configuration, control, and development of on that machine. And you would have local storage. Essentially, the system uses the local file system. Right. Currently, there have been a great deal of progress, particularly on Linux kind of a type of machines where you can short circuit many things and bypass lots of things and just stay in the kernel mode. It's kind of a special system low calls which allow you very fast processing. It's like if you're familiar with Kafka, they use the same thing. So I guess the Linux kernel has advanced to a point where essentially you don't process certain data on heap in the user space. Things happening in the zero level, system level, without going back and forth, losing some kind of a microsecond type of latencies. Okay, we've got flow controller. Essentially, this is the actual bus, messaging bus, where you can connect one processor to another or to the external, non-local, remote controllers. So you've got flow file repository where that message is essentially the message is just, I guess, indexed in the flow file repository, and the actual message, while it gets persisted, sits in the content repository. It's kind of a queue. So it's queue, and if the recipient of the flow file not available, so content repository would keep the file around. Provenance repository, that's where timestamps of the messages would be handled, the size of the message, some additional meta information, so that next time around when you need to reconstruct the flow, you would be able to contact every host, NiFi host, and stitch that information together, so that in your screen on your web console, you will see a very nice kind of flow chart. So can we integrate with Cloud Foundry? I believe you should be able to do it. Cloud Foundry is specific to Spring, to Pivotal, right? But I guess you can create your own extension, essentially put your Spring application on top of NiFi. I don't see any reasons why not. It's JVM, and it's not kind of a proprietary JVM. It's a real deal. Okay, so I guess if it doesn't have it, I haven't checked, but you can always create your own. So that's where that extensibility of the system really comes and helps you. Clustered architecture, that's where things become really interesting. So you might have gazillions of those servers, right? You might have 3, depends on your kind of your budget. Recently, they have re-architected the system, and they introduced Zookeeper as a system, which acts as that coordinator of transactions and electing the leader, the primary node. So essentially, it's a cluster where a particular node is elected as a leader, and if that leader comes under the water, then Zookeeper would recognize that fact within that short interval that you can configure. It might be 5 seconds, 10 seconds, and then a new election process starts, and another node would become the primary node. So Zookeeper is it's Apache product which is widely used. For example, in it's a standalone project which is highly used in the Hadoop ecosystem for HBase, for managing high availability. Essentially, whenever you want to have high availability, people just immediately come up with, okay, we need to use Zookeeper. So Zookeeper in itself, it's not just one server, it has an ensemble of servers, so it has high availability in its own. So if you need Zookeeper, you can get by without it, but in real bulletproof deployments, you need to have it. Okay, so essentially you just replicate those things. And whenever you log in, right, so you started to that NiFi process, and essentially it has built-in web server. You connect to it. Default port is, I believe, 8080. In some production environments, it might not be the case. And that's the actual your IDE, which allows you to start building your flow. By the way, currently NiFi already carries proudly the logo of Hortonworks. It's for data flow. They have an HDF platform, which is separate from HDFS, from Hadoop. And that data flow is nothing more than NiFi. So that's your integrated environment. So it has processors. It has you can cluster processors. You can edit certain things. You can start the flow when you build it. You can stop it. You can get metrics. You can delete it. So lots of the things that you would be familiar, like using Eclipse-based environments or Visual Studio. So that's exactly what it is. Adding a processor, so essentially you click on that nice processor type of icon, and you would get to the screen which would allow you to narrow down and find the most suitable processor. Currently, there are 200 plus. More is added, and you can deploy your own, so that will become part of that ecosystem. On the left-hand side, it has that term cloud, which is sensitive to your typing. So if in the filter window you start typing in, let's say I would like to do something with SQL, right? And it would immediately narrow down that list. It's kind of a responsive development. You will have SQL specific, so you'll have connectors to Oracle and whatever system you are interested. JMS, Kafka, just putting files, moving files around using FTP, just saving the files and uploading files. Integration with AWS secure storage, with HDFS, all the things. So probably, I guess you can find if the cloud Foundry is supported. So there is question. I have recently found that expression language EL support is quite inconsistent in built-in NiFi processors. NiFi version 1.3. For example, Invoke HTTP supports expression language remote URL attribute, but does not support the use of EL in basic authentication, username, password, and some other attributes. So I can call various URLs driven by my custom property file, but I cannot modify the username dynamically. It would be great to have all attributes accepting EL expressions. Is there any reason for such EL support inconsistency? I would say I'm not familiar with that. That's a great question. It looks like someone is like Valery is using it. Looks like very extensively. Usually this is an indication that something is out of whack, because the system is growing out of maybe at such a fast pace that they kind of have these inconsistencies. I think it's a problem of the growth. Originally, NiFi, when it was adopted, had like around 100 processors. So another probably 100 were added quite recently. And maybe Hortonworks doing a great job in this department. So one thing would be to add Hortonworks is currently your contact if you really want to bring the attention to this point. So you can contact them. Maybe they will issue a patch for this particular feature, or it's an open source. It's Apache Software Foundation. You can find where it's actually happening, and you can contribute to that product, and probably call yourself a contributor to NiFi project. So two ways, right? My experience with Hortonworks products is that sometimes they are so much at cutting edge that they haven't properly tested some of the software, right? And it's just they have this kind of an internal culture. Okay, so I cannot really comment on that any further. So the Pivotal Cloud Foundry integration for NiFi. Yes, that's so. I guess was a question originally from Navin Bohadi, if they have Cloud Foundry integration, and that's my answer was, maybe you just joined us, I'm not sure, Abhijit. What you need to do when you have NiFi installed, just go to that processor and type in filter. I currently don't have access to it. We've got it in our lab environment. I don't have access to it at the moment. I cannot verify it. And just try typing Cloud Foundry. If it doesn't come up, that's one thing. Probably very slim chances that it's there. If it's not, because essentially Pivotal is just trying to become more and more proprietary type of thing, but Spring integration are sort of open source. You can create your own processor. So next time when you click on that icon, it would show up here. It will have a title, kind of a label, and that's it. You can contribute it, and you become a contributor to this Apache Software Foundation project. Okay, so that's the point. Okay, moving on. Processing, data transformation is something that near and dear to lots of people. So you need to deal with encrypted contact, text replacement, regular expression, transformation, back and forth, JSON, XML, character set conversion, and compression, decompression of the content. So those flow files, essentially the payload. It's kind of a it comes with some meta information, but that blob or glob which comes with it can be anything. Right? The system would describe what it is, but it would be up to you to really slice and dice the content the way you want. So routing mediation, that's another ESB strong point. To control the rate, to enforce back pressure, detect duplicates, so that would be already at the application level rather than at the system level. Route on content, meaning that you would essentially parse, if it's an XML, XPath type of lookup, you find a particular interesting point. Okay, you've got, is it for approval, or is it for rejection, or is it for what? Essentially, the system would be smart enough. Scan content, you can have a dictionary of objects. Probably it would be something that you can probably implement, that sentiment analysis. You launch a new product and you connect it to the, like say, Twitter, Firehose, RESTful endpoint, and you ingesting the data related to your topic, your hash code, your product, and you just in real time you check the sentiments of people. Are they happy? They're constructive, or they just absolutely kind of pleased as punches? They are absolutely kind of fascinated by your product. So scan content would be the product, the processor to use. All the major databases supported. I guess you can develop your own attribute extraction. It's kind of a dictionary type of thing, meta information, without actually going into the message itself. Integration, data ingestion. As you see, FTP, JMS integration is there. DFS, S3, it's Amazon. Essentially, you would need to set up an account with Amazon, and you can get file. And by the way, you can put the file in the cloud. It's secure as well, end-to-end point are secure. And essentially, you've got the cloud integration. So I guess something along those lines can be done with Pivotal Cloud Foundry. Okay, so you will have something like fetch an object from that pass. Okay, emails. You can add an email attachment probably and send it the old-fashioned way. So configuring the processor, probably it's self-evident that the processor would need to be configured in some way. You should give it a name. You can disable it. By the way, whenever you see nar or something like this, nar means it's .nar. It's a NiFi archive, essentially jar file with some additional meta information. You've got a failure and success. That's the way to fork processing. So what happens is, for example, if the file is corrupt, okay, we just create a message, the file is corrupt, and put it in some sort of a repository. Usually it's just a directory on your local file system. Properties, you can specify directories, file filter, regular expression, path finder. Essentially, lots of things can be configured. And this is only for the put file. So that put file is a way to take the file which just became visible to that put file processor, which is essentially your processor, but it's based on that put file functionality. And you store it, you put the file into that directory. And there would be probably a listener process which would pick up the file. Lots of things are possible. So a simple data flow is built by dragging that processor icon, selecting the processor types that you're interested in, and connecting them with links. You just connect the output of that previous processor in the chain, connected to the input ingress point on the next. Essentially, we've got three processors. So the final one would contain, it would be the final node in your activity diagram, if you will. So we get the file, we can get it over network using any of those connectors. We scan the content. We need to provide logic for that. Or you can, I guess, use the pre-canned solution, like just selecting the proper words that you're looking for. And then if the content is satisfied, you can enqueue the process to the final process. And by the way, you see those green arrows. It's a good visual to see that the process is up and running. Currently, there is nothing happening, but over a period of time, you will see that certain statistics metrics are showing up, like how many bytes have been written, how many bytes have been written out, the task time it took. By the way, if a particular processor is down, that queue would start showing in queued requests, so that depth of the queue would be increasing. It happens every 5 minutes. You can configure that so that the refreshing would happen more frequently. And usually you would probably start doing development with very short interval, maybe 10 seconds, and then would eventually increase it to something. Okay, so data provenance, it's a big thing. That's probably one of the appealing factors, one of the driving forces, is that nothing really disappears in the system. It's kind of a write-ahead log type of thing. So first it would go into that provenance repository, and then the message would be accepted. If a message cannot be accepted, then it would be rejected, and the record would be purged from the repository. Right. The picture is not very blurred because it's borrowed from the Apache NiFi. But the point is here that we've got timestamp, we've got type of the message, the operation, we send the data, we modified attribute, modified content, and then we have the hash code to uniquely identify that message. Size and component name, what actually was the operation applied to it. Okay, and you can drill down by clicking on that thing further. Okay, so essentially you've got a very efficient auditing trail. That is absolutely indispensable for those people in banking and other mission-critical contexts, environments where you need to have, because of those compliance requirements, regulatory policies require that you really keep track of all those things. So it's already built in, so very nice. Provenance, so again, so when you click on this thing, right, on the right, you've got the data provenance diagram. So essentially it would show what happened to a particular message. Okay, so that's a flow file, that's a message that was going through. It was send, drop. Join means that it was kind of picked up. You can download it as an image. You can return to the event list back to this one. Okay, so essentially you would have someone from security or sitting with that ombudsman representative and just going through those things, trying to stitch together. It is searchable. I believe you can do lots of things. It has a filter, and you can narrow down quite easily. Okay, so that's I guess it for provenance. Status history. It just shows you what's happening with your flow, right? It just gives you some statistics to show those spikes of activities, and you can probably start figuring out if you need to kind of bolster to harden your system. Okay, and NiFi is currently having very good integration with HDP, HortonWorks data platform, workflow system. It has Ambari digital UI, and you can pull out those statistics and display in in the consolidated view. Okay, so that's it for me for this presentation. So unless you have any questions, and by the way, there was a question to provide the slides, so let me do that right now. I believe I can help you now. Just give me a second. I'm going to put the file into the what's called handouts section. Okay, so that would be, I guess, my plan to do. So there was a question how to save the outputs into HDFS. You will just take the file, that flow file, and put it in HDFS. There is a connector to HDFS. Yes, you can do it. Sure. Mm-hmm. Okay, so what I'm doing now is I'm getting that slide deck PDF and I'm dropping it in handout section. So it has been uploaded. What you can do now is just to get the file out of that handout section. It's a pane that you can use to get the file. Okay, so we did that. Okay, any more questions? 2 more minutes. If there is no questions, then I'll need to shut down the session. So there is another question. Do you know if there is any extensions that would allow some spatial capabilities? I'm not sure if I understand the question spatial. You mean spatial matrices? Or Dara, please elaborate a little bit. I'm not sure if I understand. What is the main difference between NiFi and Flume? Well, Flume is just messaging system, which is to a certain degree does the job similar to what NiFi does, but it has fewer limited processing, and what NiFi also gives you, it gives you bidirectional access. So you can do things in the reverse order. If, for example, you need to custom to affect, for example, this use case scenario. So you're getting the data in a very kind of a broad brush, so to speak, very coarse-grained. And then if you find something very interesting, for example, you see that this particular segment that you are scanning at the moment, those sensors, they should start picking up more signals. It can be anything, right? So you have a feedback loop that would allow you to have NiFi to connect to that remote processor and essentially cause it to start increase the frequency at which signal is broadcast. Okay, with Flume, you cannot do it, as far as I know. Okay, so so another question is, so Dara, you essentially came up with the answer yourself. So come up with a custom processor. If you are referring to, okay, like manipulating geographic data, for example, yes, I guess with the spatial data with the just longitude and latitude data, I guess you just need to have something like probably like HBase on HDFS. Ingest the data there, perform some processing, and then ingest it in a more consistent way. I guess HBase is very well targeted for that system. Probably you would be better off not to use NiFi, not create your own kind of processor for NiFi, but rather use HBase because it was exactly created for with that kind of a picture in mind. That's a use case for highly, very scarcely populated matrices. Okay. Yes, okay. Could you please comment on NiFi versus Kafka? Well, Kafka essentially it's just a distributed transaction log, nothing more. It's very simple. It uses some of the efficiencies provided by Linux kernel, like bypassing. Whenever it starts processing, sometimes it just bypasses that heap processing. It just takes kind of a feed from your hard drive, actually from the socket, and if you would like to persist that socket flow content on a file, essentially you don't need to go through your heap, through your Java process. It will just immediately short-circuit it, and it will. There is a way now to essentially connect your system directly using that low-level processing, so that there is no interrupts involved, and your performance just boosts like 1 or 2 orders of magnitude. So, but Kafka essentially it's just nothing more. It's very hyped, I guess, overhyped kind of a system, but it does the job. It has very kind of a good use case. It's just a messaging system which accepts and moves around messages in a very efficient way. It has lots of robustness built in, but it's nothing more like that. It's just probably Kafka is just one of the processor on top of NiFi, but definitely Kafka will beat hell out of NiFi if it's really set side by side for use case to ingest kind of millions of messages per second. So NiFi is not suitable for that. The question is, does NiFi require its own cluster? Yes, for sure. And I guess, or can it be co-hosted on a Hadoop cluster? I think NiFi should be deployed outside of your existing. It should act as a client to Hadoop. So it will be another product in the Hadoop ecosystem. So it has nice integration, bidirectional, put get. It can also connect to systems that can run on in the Hadoop product ecosystem, right? So essentially, that would be a very good, I guess, mode. You have your data center, which would have lots of systems, and Hadoop would be probably a centerpiece. It would be like data lake, all those capabilities for redundant storage with MapReduce and everything. And NiFi would just happen to be another one, another key on the block. So there is an additional, I guess, looks like I've got so many questions. So if we can expect data ingestion to be sporadic. For that, if it really upsets your system, NiFi flow, then you're right. You can say, Mladen, you can take, it's kind of this way. You essentially take your ingestion request directly going through Hadoop, and then you would use NiFi to get and move things around further. But usually NiFi is positioned before Hadoop, so that it just acts as that ingestion point direct. Sporadic, non-sporadic, ad hoc, non-ad hoc, steady. You need just to have that ingress point. NiFi would be a nice place to be. Okay, any more questions? Yes, Mladen, you're welcome. Okay, Jay, you're welcome. Okay, guys, thank you for attending the webinar. Interest seems to be quite high. So looks like people have started evaluating the system. Okay. Abhijit, Louis, thank you for attending. Okay, guys, all the best. I guess I've sent you the slides. Bye-bye.